If you already did 3/6 the old way,
Oops. For the extra credit, you have to do it the matrix way. Yeah. Aw.
aw,
Because what's the extra credit about? It's about matrices.
Fight me.
Wow.
I will grade you harshly if you're not careful. So, what's really important here? What do you focus on? What tells you what to do? If you were going to do this by hand, what would you do to solve this?
Times it by 2. Times
Yeah,
it
multiply by 2. What told you to do that specifically? The -2. How much do I care? All I care about is that these are both the same letter. Couldn't they both be A's? So what's really important here are just the coefficients, right? The fact that this was a 1 coefficient is awesome because the 1 can become anything I need it to be. So that's why the first step in a matrix is don't write the variables. Just make sure that they're all lined up correctly, right? X's, Y's, and then equals numbers. Then what's really important are just the coefficients, the numbers. So the matrix would look like this. 1, 3, 7. -2, 5, -3. That's what the matrix would look like, right? Not as interesting as the movie, but too bad.
I know, I'm trying to figure out how did that tie into that?
Why do they call the movie The Matrix? I'm still trying to figure it out.
But it sounds nice.
Yeah, it sounds, yeah, people don't know what matrices are, so,
Computer
yeah, let's call it matrix.
Yeah.
which is exactly.
Yeah. So here, I'm going to kind of do the work by hand and show you what the work looks like in the matrix at the same time. So what you told me was you would take 1 and multiply it by 2, right? And of course that would make these cancel eventually. So if you do this, 2x plus 6y equals 14. Cool. Just multiply that by 2. This would die. You get 11y equals 11. Can somebody tell me what's the best equation up there right now? What's the best equation up there? And this tells me who read that handout. Because what defines the best equation is the one with the least unknowns. So of course this guy is the best equation up there. These two are still true, of course, because we can plug back into either one. They both must still be true. But do I really need both of them right now? I just need that one for right now, don't I? So a matrix will always keep the best equations yet. So it doesn't grow, it just overwrites shit. I don't need to write the same thing over and over again. I replace one with the better one. So let me see if you guys, do you see how this is really 0x, of course? We don't write that because that's silly. But there would be a 0x and so forth. So in a matrix, what I'm trying to do is I'm trying to get zeros everywhere. In fact, my goal in a matrix, let me do a little side note here. A little side note. I don't know what your notes look like, but oh well. Can somebody tell me, let me show you a couple of things real quick. Can somebody tell me what the two equations are here? What are the two equations there? Right? And then, okay, cool, right? Okay, good. I just want to make sure we can go both ways. So I went from here to here, and we can go from here to here, right? So what's really kick-ass cool about this one here? What equation is this? X, no y's is 2. No x's, 1y is -3. Hey, I know the answer then, don't I? I'm not saying that's the answer, by the way. I'm just saying. If I can get it to look like this. So see, whenever I get a 0 in a matrix, what does that really mean? I killed that variable. And again, remember, what are we trying? What's the whole purpose here? To kill a variable. And I get a 0, don't I? So in a matrix, I'm trying to make it look like this. 1, 0 number, 0, 1 number, because then I know the answers. I can just read them right off, right? So in this one, to do the same thing we just did, I would take, what would I do to row 1 to make this die?
Multiply by 2.
Multiply it by 2. So I would take twice row 1 plus row 2. And do I still need this then? No, I'm going to replace that into row 2. Now here's where I'm going to lose a few people for a minute, but try to come back to me in here when you can. We're doing the same damn thing, right? This is an equation. This is an equation. It's just saying, why do I need to write the damn variables down all the time, right? They're still equations. I can still multiply them. I can still add them. So here's the idea. See, I'm going to show you the full way from the beginning. What do I get if I multiply this by 2? Don't I get 2, 6, and 14, right? So if I add 2 to negative 2, what do I get? 0. 6 and 5, 11. 14 minus 3, 11, right? Do I need this eternally multiplied by 2? Why did we multiply by 2? Just to kill this guy? Isn't he dead? Do I still need to multiply by 2? No, I can just leave it alone, back to 137. So, let me say again. We multiply this by 2 so that those will die, right? Now I know what y is, don't I? Divide by 11. Could I plug the 1 back in here? Or here, right? So is this not here anymore just because I multiplied by 2 for a minute? No, this is still here, right? In fact, it's a better equation than this because the coefficients are smaller, right? So what I say about matrices, they always keep the best equations. See how I just put the numbers up here for just a second so I can add them? Why would I keep it 2, 6, and 14? Isn't 137 better than that? Are they the same stupid equation, right? This is the same as this, aren't they? Of course they are. So why use 2, 6, and 14? Just use 137. So I only change one row at a time in a matrix. But you see how it makes the organization a lot easier, right? And the big thing is people getting used to how matrices work. It's just the reorganization of what we're doing. And people hate it because you guys don't have the motivation necessarily to see why it works the way it does, because it's easier to do this anyway, by hand, right? You're like, why would I do all that shit? Let me just do this. So I'm hoping you guys come with me a little bit. Now, can you guys see what I can do to this row? Gonna divide it by 11 the same way we divide by 11 here. So to take row 2 divided by 11. So the first row is still the same. The second row is now 0, 1, 1. So what's this say right now? It says x plus 3y is 7. And this says y is 1. Right? So see, it's the same things we know over here, isn't it? Let's just look at all this crap. Do I need all that crap? No. Matrices said, no, why do you need all this shit in the way? Let's just get right to what's important. Now, look at the goal again. Isn't the goal here? Because then I know what y is, and I want to know what x is. So what do I have to have happen here? What do I need to show up now?
That 3 to be a 0.
I want that spot to become 0, don't I?
Mm-hmm.
You never ever want to do anything that will make a 0 go away. Because your whole goal is to make zeros. Because what does that mean? You killed a letter. You want to kill letters. Why? There's too many of them, right? It's not some evil, even Ebenezer Scrooge. Surplus population killing. But we know we want to kill them because there's too many of them. So we kill one of them. Now I want to kill that one.
So
How do I kill it? Yeah, multiply row 2 by negative 3 and then add, right? So on negative 3, row 2, plus row 1, where do I want to put the answer I get? Do you want to mess with row 2? Row 2 is beautiful. I'm going to put it overwrite because this equation now is not going to be good. It's not going to be as good. I'm going to replace it with what I get. And again, this is why I made this extra credit, because we got a lot to cover this semester, and this is not quite as important as some of the other stuff. If you're going into those courses, the 178 or the calculus, you definitely want to try this for extra credit, because that's going to come back when you get to those courses. Yeah.
In the 16-week class, is this part of the class?
Oh, hell yeah. Yeah. So let's see now. Let's see if you guys kind of get what I'm about to do. So if I multiply this by negative 3, 0 is still 0, right? 1 is now negative 3, and 1 is now negative 3. And I put it here because I don't really want to change this, do I? I don't change this row. It's still 0, 1, 1. Why would I want to make it 0, negative 3, negative 3? That's stupid. I just want to make it negative 3 there for a second. Because what's 0 plus 1? 1. Interesting. What's negative 3 plus 3? There's your 0. And then what's negative 3 plus 7? 4. So now what's the answer? X is 4. Y is 1. Now again, I know that a lot of you guys still haven't quite caught on to what I was saying earlier, and you're going, the freak, what? What? Screw that, I'm going to always do that. All right, great, that's fine, I love it. So this way is definitely at least as easy as that way for a system of two equations, right? Here I would just plug a 1 back in, get x plus 3 equals 7, so I get x is 4, and I'm done, right? Okay, maybe. But let me show you, let me see if I can do this real quick. If I had a system of 3 equations, did we have one? Let me do one from the book real quick. Or was that too freaky? That's fine. One of the most frustrating things, by the way, I'm sure some of you guys might have picked up on this, is the minute you forget a negative or transpose some numbers, your whole matrix goes to hell. Because it keeps playing with all the pieces, right? The minute you put something in the wrong place or forget a negative, forget about it, you're dead. So the bigger your matrix gets, the more chances there are for you to make that kind of mistake. Trust me, I've done 6 by 6 matrix by hand, going all the way through, and you're like, way up here, step 2, I put a 2 instead of a 3. I'm like, I get down to the answers like 14.8. I'm like, oh shit, I forget. Oh shit, you're screwed. It's too bad. So it's user error. You gotta be real careful if you're gonna do this. Yeah.
So for the extra credit homework, we have to show all of that, or can we do it on the calculator?
You have to do all of that. Yeah, I might show you how to do it on the calculator here in a minute. But what would the matrix look like for this? Don't freak out. What would the matrix look like? Making the matrix not too bad.
1,
One negative
1, negative 2, good.
Negative 3.
3.
3, I like it.
3.
2, negative 1, negative 2, 4. 4, 5, 6, 4.
I like it. Cool. All right, so making that matrix is pretty easy. I know. Somebody's gonna walk by and say, the nice thing is, this is not always going to happen. But see how I have a 1 right there? If that equation would have been last, the very first thing I would have done is to switch those. I want a 1 right there. Can somebody tell me, now with the 2 by 2, my goal is this, right? Number, right? What do you think the 3 by 3, what my goal would be? 1, 0, 0 with a number? 0, 0, 0, 0, 1, 0, and then 0, 0, 1. 1 diagonal ones. So I got a 1 right there. Here's the way to do this in a very meticulous way so you don't mess up. Because if you do it out of order, sometimes you'll kill a 0. You never want to kill a 0. You never want to lose a 0. Zeros are good. We want to make zeros. You want to do the first row, make those zeros. Then move to the next row, make those zeros. Then move to the column. Move to the next column, make those zeros so you match it up, and then the answer will just be sitting there waiting for you, right? All right, so let me just do a couple steps. I don't want to do this all the way out. I just want to show you what this would look like. What would I do to maybe kill this guy?
-2.
Beautiful. So -2 row 1 plus row 2. And I want to put that into row 2. So if I do negative twice row 1, I get a -2 there. What do I get here? Multiply by -2.
4.
Positive 4. Positive 6 and -6. Cool. Now you could do it where you rewrite the whole matrix and you put those numbers in, but you see how that's kind of going against the whole idea? Matrices are supposed to cut my time down. So what's -2 plus 2? 0. Which is cool, and that's what I'm working for, right? Those zeros. 4 minus 1, 3, 6 minus 2, 4. Good Lord. -6 plus 4. -2. Does everybody see that? I'm just doing exactly what I said I want to do. I want to kill that 2, make it a 0. So effectively, what have I done to this equation? I've canceled x out, right? Or in this case, it's p.
They're redoing the roots.
Shit. Well, yeah. Everything else stays the same. So this is a slightly better. I keep waiting for somebody to come through and join us.
They will. They will.
Yeah. This is a better matrix than that because it's got one variable canceled, right, eliminated. And then what's the next step? Do what we just did, just do it with this. So what would I multiply the first row by now? Yeah, -4 row 1 plus row 3, and overwrite this with the answer. I want a 0 to show up right there.
Can you switch row 1 and
If you ever wanted to, you can switch rows. In this case, it wouldn't make sense because I got my 1 there like I want, I got my 0 there like I want. I just want to make a 0 there. I don't want to switch anybody.
row 2 and row 1?
If you wanted to, sure, but there's really no reason for it. If you wanted to, sure. See, where am I? So if I multiply this first row by -4, I get those, right? They are just dancing. That's what they're doing. They are dancing. Yeah.
What does the arrow mean in the matrices formula?
Oh, do this and put the answer there.
Oh,
Do you see that?
okay.
You pick where you want to put the answer. You overwrite one of the equations. You're not going to overwrite the good equation. You're going to overwrite the equation that you got a better thing for now, right? Think about, I want a 0 to show up there, so where are you going to put the answer? There.
So that basically says, after you do this equation, the answer is gonna go in row 1.
In
the
place of
next
that old
matrices.
equation. Because I always want to keep track of the best equations. It doesn't mean these equations are no longer true. It just means my matrix has the best equations I've found so far in it, right? So this equation here, this would be 3q plus 4r equals -2, right? That equation is better than any of these because it's got one less letter, one less unknown. So the next step, if I do this, -4 plus 4 is 0, 8 plus 5, 13, 12 plus 6, 18, -12 plus 4, -8. Everything else stays the same. Cool, right? Now, I'll just show you the next kind of step. Do you see any 1s here?
No.
That sucks, but it's not terrible. You can still, like between these two, to make that a 0, you can multiply this by 3 and this by 2. Right, to make them both 6 and -6.
Mhm.
Do you see what I'm saying? The more comfortable you get with this, what do I get if I multiply this row by 4? What do I get right here? 12 and so forth, right? So if I multiply this row by -4, don't I get a -12? And if I add it to this, don't I get a 1 there? I can make a 1 easily. Why are 1s so freaking cool?
Because you can change.
Because they become whatever I need them to be, right? They're like my lasers. I always think about it as like surgery. If I have a 1, I can go in there and kill this guy and kill this guy, right? So if you can make a 1 here, great. If you can't, it's okay. You can still multiply both so that they'll cancel. Yes, ma'am.
Yeah, so when you go from row to row, the first thing you do is to find a 1, not to find any zeros, even if it's easy to get a 0, even if you see it easy.
Well, if this was a -3 and a 3, then I wouldn't. I wouldn't make a 1. I'd just go in and add those 2 rows together because then the 3 and the -3 would cancel, right? What I want to have happen now is to make a 0 there and a 0 there.
Also, the first step is to find the zeros. I mean, to make the zeros.
To make the zeros, yeah.
Not the 1s first.
Right now, it's not easy to make zeros, is it?
Right.
So maybe you want to take a second and try to make one of these become a 1 there, right? And again, I have no idea how many of you guys are kind of with me right now. I think, let's see what reaction, okay. I didn't give you a chance to make a reaction to that statement. I'm sure somebody's going to go, not really. And I understand that. I totally understand, because you guys have probably never seen anything quite like this before.
No.
Unless you've done, has anybody ever heard of synthetic division?
Yes.
Now that's going to freak people out, I know. Synthetic division is a lot like this because it just takes the variables out of there and only puts the numbers, because that makes sense. If you've never seen anything like this before, I totally understand that right now you're freaking the hell out. That's why I wanted to make this extra credit so it doesn't totally freak you out. Okay.
It's the president.
No. So you could, right here, if you wanted to, multiply this one by 3, and this one by -2. Do you guys see how that would, not -2, but just 2, that would kill those? I know I wouldn't have a 1 here anymore, but 1s are not as important as 0s. 1s are nice, 0s are imperative. Yeah.
Okay, so if you multiply the the first row by 3 and the second row by 2,
Yeah.
right? And then you get 0 and 6 and 8 and -4.
Okay,
Okay, so you have to add row 1 and row 2 together.
good. Where's the answer gonna go?
Well, isn't the row 2, the 0 gonna become 3? If you're adding 3 and 0?
But you're gonna
Yeah,
keep
the
the first
one,
equation.
so you just answer your own question. Do I wanna put it here where I'm gonna lose the 0?
No.
So I'm gonna put the answer here. So I don't lose this 0, right?
Right. So then the 0 is still gonna stay the 0, but the 1's
Beautiful.
gonna become 3.
I like it. What did I just say? Ones are nice, zeros are imperative,
Yes.
right? So if I lose my 1 here, that's, why is it not so bad? Because I already used that 1 to kill these guys. That 1's usefulness has already been used up. What's more important is making that guy 0. Remember our goal? See, these are the 2 zeros I'm working on now, right? I made these 2 zeros. I want this to be 0 and that to be 0. So if I add these 2 rows together, I'm going to put the answer here, so that the 0 shows up right there, where it's supposed to be. So here I get 0 and 3 is 3, 6 minus 6 is 0, 8 minus 9 is -1, -4 plus 9 is 5. Everything else stays the same. And now you do the same thing now between these two. If you wanted to, you can multiply him by 13 and him by -3. Your numbers are going to be big, but at least they're not fractions or decimals, right? You can still work with big numbers. But the idea is what's important. The idea. Make this guy a 0. Once you get that done, then you want to make this guy a 0 and this guy a 0. And then you're there.
When you do the math on it, like, just say for instance, are you still able to keep the old one if you want, if it made the next one look better? If it made the next matrix look better, could you still keep one of the old lines even though you multiply?
You could, but normally you wouldn't want to overwrite one of these with the old line because these are better than that one is.
Because I was thinking to keep the one there.
But what was the whole purpose for what we did? To make a 0 here. And if you keep this line, it's not a 0 there anymore. Right?
Okay.
Let go of the ones. Ones are nice, they're not necessary. At the very end, I need it.
Okay, that was my problem.
Maybe I should finish this one out. And again, if you kind of written this off, you're going, I'm not going to do this shit. Great. Sit there. I like it. Just watch and see what you can absorb. If you're going to try these, this next step is going to be a little bit ugly. Remember, I've got to multiply this by 13, because the LCD here would be 39, right? 3 and 13? Multiply this by 13. Well, what is that, Jeff? 52? Yeah. 13, -26. Multiply this by 3. -3, actually. Got to make them the opposite signs, right? This is still 0. -3 would be -54. And 24. That looks yummy. And then you get, now I wanted to at least do one more step. So the first stays the same. I know some of you guys have written me off a long time before. Again, I'm just multiplying each of these by what it's needed to, so that these will cancel, right? Where do I want the 0 to show up? At the bottom. So 0 plus 0 is 0. 39 minus 39 is 0. 52 minus 54 is -2. -26 plus 24 is -2. And that stays the same. What's really nice there? You know the answer to one of them already. If you divide this by -2, you get R equals 1, don't you? If those both cancel. Now I know R is 1. If I divide by -2, make that a 1, that 1 could kill that, that 1 could kill that. You guys see what I'm saying? So let me do this before I totally turn those of you off that have already. If you want to, you can stick around. I'm going to go ahead and take a break. And I'm going to kind of finish this one out. So if you really don't want to see it, go ahead. So take a break until like, I'll maybe give you a little bit longer break, 10:30. Right? So come back at 10:30. I'm going to finish that one out.
I see why they call that movie The Matrix. Because then after you finish it all, then you know Kung Fu.
Then you know Kung Fu, exactly.
Instead of being all.
So I guess my tendency is that whenever you do add, I just say R1 like you did, you added
R1 and R3?
Yeah. I guess I wanna take that 39, plus negative 39 and cancel both of those out.
I see, but then you'll have the same thing on both. Then you don't
Right, yeah,
have
that's
three
what I
pieces of
did.
information anymore, you only have two because you repeated one of them.
Right.
You never wanna lose your three
So
distinct pieces of information, that's why only one row should really change at once.
Okay.
So you only change one row, so you don't make that
So you
mistake.
figure out which one you're gonna keep, basically.
And actually what
whenever
keeps you straight is, where do you want your zeros to show up?
Right.
I'm not gonna put the answer here, cause I don't want a zero here, I want a zero there. That's where I wanna keep my one, so I can see what Q equals, right? That's gonna be my Q equals something.
Okay.
Cool.
And you kept 0, 3, 4, -2 because it's smaller than 0, 13, 18, -10. And your final one.
Oh, at that point, it really didn't matter, Tayana, you're right. I could have switched those, like you were saying earlier. If I like these numbers better, in this case, I don't really like
They're
them.
bigger, so it's like.
Yeah, I do too, somewhere. So to finish this one out, it's kinda nice, I've got my core group here. So, let me just rewrite it over here real quick. Let's see what my 0, 2, 0, 0. So if I divide that last one by -2, is that cool? I get a 1, 1, right? Divide that last row by -2, you get 1, 1. And that kicks ass, right? 1 is nice, not necessary, but is nice. So we got a nice situation here. I got a 1 here. So how do I kill that one? What would I do with row 1 and row 3? Just add them together. Because won't that kill that? So I take row 1 plus row 3. Put the answer in row 1, that's where I want the 0 to show up, right? So 0 plus 3 is 3. 0 plus 0 is 0. 1 minus 1 is 0. 1 plus 5 is 6. And you see why the 3 doesn't really bother me? Because at the very end I can divide by 3. So losing my 1 somewhere in the middle is not a big deal, because I can always divide by whatever the hell it is to make it 1 again at the end, right? So I leave everything else alone. And some of you guys see, I mean, if you get to the point where you feel pretty comfortable with these, you can do two things at once. Because here, how do I kill the 4? Multiply this row by
-4.
-4, exactly. So -4 times 0 is 0, and then -4 times 1, -4 times 1. And then if I add this to this, the first row stays the same. 0, 3, right, 0 plus 0 is 0, 0 plus 3 is 3, -4 plus 4, 0, -4 minus 2, -6. And I'm there. Divide this row by 3, divide this row by 3. I can read off my answers, kind of nice. So if I divide the first row by 3, I get this, divide the second row by 3, I get that. So what's my answers? What's P?
2.
2, P is 2, Q,
Negative.
-2, R is 1.
So the third one down, you would write it as 2, 3 plus,
Oh, so-
2, I'm
yeah, if you wanna
sorry,
see
2R 3 plus,
Where are you at here? Oh, here. It'd be -4, R3,
oh, I'm sorry, -4
Right.
R3.
plus R2, so
2
R2.
R2, okay.
So you can put a 0 right there. So again, the reason people hate this is because it's a shift in how you look at a problem, right? And a lot of us are having trouble with the damn thing in the first place, and now you're gonna shift it on me. But I'm hoping you guys can see the utility of it, and after a little bit of practice, these things get to be easy, believe it or not. Because it's always the same. If I make a bigger one, who cares? Find a 1, kill everything. Make another one, kill everything. Make another one, kill everything. It's the same stupid idea, I don't care how big it gets. That's why it's so easy to program. You tell the computer, make this a 1, kill everything. And the computer can do all the freaking multiplying and adding easy, and it's quick. So this is how they program calculators and computers to solve these kind of things, using matrices.
So you did times -4.
Okay. So it is extra credit. I desperately want a few people to try it out. At least now you've all been exposed to it. So when you get to business calculus or something, you can't say, I've never seen it before. You say, yeah, I've seen it before. Yeah.
So when there's like 2 equations, cause I started the homework, but when it's 2 equations and you make one of them into 0,
Yep.
which equation do you choose to take over to the next matrix.
We follow you along here.
Right, cause this one's
12,
3.
15, negative 3, 2, 13, okay, we can, so then you get a 0,
It doesn't erase it right now.
So which one do
14,
you write
and
on?
a 28. Oh, that's why, 28 there,
Right here?
right, and 13 and 15? Otherwise, you would've gotten an ugly answer, which I wouldn't expect.
3,
13 and 15, 28.
Oh,
No, 5's fine. Because you decided to put the answer in the first row,
oh,
which
yeah,
is not,
28.
which is fine. It's not normal, because normally I want a 1 there, and so normally we would put the answer here. But I think you just liked this equation better, right?
Yeah, 'cause it was a smaller number.
Which is fine. So you do have some flexibility here.
See, it doesn't matter which one you pick.
It doesn't
whichever one.
truly matter. The reason that we have a very set way we want it is so you don't get lost in the process, right? But the more comfortable you get with it, the more, there's a lot of flexibility. It's just that if you're not comfortable with it, that flexibility makes it harder. Because you're not sure when you can do what. But on a 2 by 2, it's not that bad. Because now, you can divide this by 14, right?
Yeah,
Make a 1 there, and you can kill that 4 easy.
and then which one do you pick to write on the next one?
Don't lose your zeros. So
So
you would
whichever one
overwrite
has
the
zero,
second row
keep
then,
that.
right? I'm not gonna overwrite the first row for anything. Because I don't wanna lose that 0, do I?
So that's the rule, whichever one has the most
You
zeros,
try
you keep
never
that.
to lose your zeros. So that
Okay.
definitely helps you with where to put an answer.
Okay.
Don't overwrite a 0, yeah. Okay.
So is the extra credit homework due tomorrow too then, or do we